Okay, students. So then you understand in binary erased channel. Then I just give once again, just explain once again. So if the signal strength means noise affected binary data signal strength is greater than threshold, it will be treated as binary 1. The signal strength is less than threshold, it will be treated as binary 0. When the signal strength sometimes it is exactly equal to the threshold voltage, then the extra symbol will occur at the receiver. So now we need to erase that extra symbol by using automatic ARQ request. What is this ARQ request? Automatic request for retransmission, which means now whenever the receiver is sensed that, so when the transmitted, the noise is added, then the signal strength is more than threshold, binary 1, less than the threshold, binary 0, equal to the threshold, then extra symbol is occur. When extra symbol is occur, the receiver is recognized that some disturbance will be appear. So in such a situation, then receiver will send a request to the transmitter. Now that request is called as ARQ, automatic request. Okay, this is automatic request. Now this request is sending from receiver to the transmitter. What is the meaning of that request? Now ARQ, automatic request for retransmission, means it indicates that the receiver will tell to the transmitter whatever you are transmitting a symbol, just a minute, just a second, please again you transmit that symbol. Okay. So now when this acknowledgement is received by a transmitter from the receiver side, so the transmitter job is, the transmitter is again transmitting the same symbol. Okay. So the transmitter is again transmitting the same symbol. When the transmitter is again transmitting the same symbol, then what happens? Then this extra symbol will be avoided. This extra symbol is erased. Sir, how you can say that? Yes, I can say that. Now there is a time when the receiver is sensed that some extra symbol, and again it will send an acknowledgement to the transmitter. Again transmitter will transmit a symbol to the receiver. It will take some time. But you know that the effect of noise is varies with respect to time. So during this time interval, means after some 10 seconds or 5 seconds or 15 seconds, so definitely the noise will be varied with respect to time. So at this instant, when again the transmitter is transmitting the symbol by receiving the ARQ request, now at that moment there may be a noise effect is less. When the noise effect is less, at the receiver side, the threshold comparator will take a right decision. It may greater than threshold voltage or less than the threshold voltage. It may be binary 1 or a binary 0. Therefore, the extra symbol is erased. Okay, that is the concept of a binary erased channel. Okay, clear or not? Right, now we'll see cascading of channels. Cascading of channels. Cascading of channels. Now, what are the possibilities of cascading the channels? Now, when the channel is cascading, now this is one fiber. So I want to lay this fiber for a long distance. Okay, long distance means now this fiber not able to transmit the signal strength to the longer distance. Therefore, so here in between these two channels, means these two fibers, optical fibers, then I just put a repeater, like an amplifier, like a booster, is called as booster or repeater or amplifier. Okay. So this is x1, y1, right? Now this is x and y. Now actually I want X to Z, but in between this X to Z then I put a repeater. So now this is some other station is coming in between. Okay, so a repeater, a cascading of channels are required. In between these two channels a repeater or booster or amplifier is used. Okay, so the cascading, these two channels are cascaded, in between there is a repeater is required, or sometimes the signal strength is very less to cover the longer distance. Now we somewhere in between these particular distance, somewhere we will put the repeater or amplifier. So we use this kind of cascading of channels. Sometimes we need to decrease the signal strength also, right? Sometimes we want to decrease the signal strength. Now that signal strength decreasing is possible with the help of attenuators. Okay, attenuators are decreasing the strength, amplifiers and boosters or repeaters are increasing the signal strength. Okay, now in such a situation generally the channels are cascaded. Okay, now see here, now this is x1 y1 with some probability. X1 is transmitted, y2 is received with some crossover probability. X2 is transmitted, y2 is received with some probability. X2 is transmitted, y1 is received with some particular probability. This is one channel. Then we want to cascade the channel. Y1 is transmitted, Z1 is received. Y2 is transmitted, Z2 is received. Now Y1 is transmitted when Z2 is received. Now Y2 is transmitted when Z1 is received. Now these are the cascading of channels. Okay. Now so we finally conclude that now this is cascading is nothing but a direct link between X2 Z, X1 Z1, X2 Z2. X1 is transmitted, Z1 is received. X2 is transmitted, Z2 is received. X2 is transmitted, Z1 is received. X1 is transmitted, Z2 is received. So now this is the cascading of channels. Okay. Now this is the cascading of channels. So now this cascading of the channels or the resultant signal, he may ask the channel capacity or mutual information or something else. Okay. So we can solve our problem. You can easily understand. Now consider the two channels as shown in the figure below. Now he is giving like this. Consider the two channels as shown in the figure with the probabilities Now he is asking to find, consider two channels which are in cascaded with the conditional probabilities as shown in the figure, then determine the channel capacity. What he is asking? He is asking to find channel capacity. So now what is the resultant? Now this is X1 is transmitted, X2 is received. Now this is the Y1, Y2. Now this is nothing but X1 is transmitted, Y1 is received, 0.8. X1 is transmitted, Y2 is received, 0.2. Now X2 is transmitted, Y1 is received, 0.2. X2 is transmitted, Y2 is received, 0.8. But you understand or not, whenever the diagonal element and opposite diagonal element probability is same, that particular channel is called as binary symmetric channel. Okay, you have to be identify that particular channel is called as binary symmetric channel. Now this is one channel. Now here Y1, Y2. Now this is Z1, Z2. When Y1 is transmitted, Z1 is received 0.7. Y1 is transmitted, Z2 is received 0.3. Y2 is transmitted, Z1 is received 0.3. Y2 is transmitted, Z2 is received 0.7. Now the resultant signal is X1, X2, Z1, Z2. Now this is nothing but a cascading. Cascading is nothing but multiplication or not, gain. So this is 0.8 into 0.7 and 0.2 into 0.3. Now this is nothing but 0.62, 0.38, 0.38, 0.62, means 0.56 plus 0.06. Therefore, this is 0.62. Now you know here, first you want to identify that. Now these are the cascading of the channels. Now the error probability is same for both the channels or not? Error probability is same for both the channels. Now this is 0.62, this is 0.62, now this is 0.38, this is 0.38. When error probability is same for both the channels, now that particular channel is called as binary symmetric channel. That particular channel is called as a binary symmetric channel. When error probability is same for both the channels, now that particular channel is called as binary symmetric channel, and this is the binary symmetric channel. This is the binary symmetric channel. Now in a binary symmetric channel, channel capacity means, now this is the binary symmetric channel. What is the channel capacity formula? You have to remember that 1 plus P log P base 2 plus 1 minus P log 1 minus P base 2. Now this is a channel capacity for a binary symmetric channel, which is nothing but 1 plus 0.62 log 0.62 base 2. 1 minus P means 0.38 log 1 minus 0.38 base 2. Okay. Now this is the channel capacity of a binary symmetric channel. Now this is the answer. And this is 0.042 bits per symbol. Whenever the channels are cascading, something like this, so you have to follow this cascading of channels. But after cascading, there is no guarantee that always a binary symmetric channel. If there is no binary symmetric channel, you know how to follow the mutual information, find mutual information, and maximum mutual information is nothing but the channel capacity. Now see here, you know that X is nothing but transmitter, Y is nothing but receiver. You know that. Where X is a transmitter, Y is a receiver, right? So sometimes he is giving like this, P of X1 by Y2. What is the meaning of that? Here the meaning of this, whatever there in the numerator, now that value you should be tell first. Okay. Now X means transmitter. Now this is nothing but probability probability of transmitting, probability of transmitting, probability of transmitting x1 if the received symbol is white. This is the meaning of that. So the probability of transmitting x1 when the received symbol is if the received or when the received symbol is white. If the data is like this, now you tell me, I will write, you tell me, okay. Probability of receiving y2 when the transmitted symbol is x1. Probability of receiving means whenever the first word, probability of transmitting means p of x, probability of receiving means p of y, probability of receiving means first is y, probability of receiving when transmitted symbol is x1, probability of receiving means p of y first, y2 when the transmitted symbol is x1. Like, okay, this is important also while solving the question. So probability of the transmitted means p of x by y, probability of receiving means p of y by x. Okay, note down these 2 points and we will solve problem. Okay, now the question is, consider the channel diagram as shown in the figure below. Consider the channel diagram as shown in the figure below. Consider the channel diagram as shown in figure below. Consider the channel diagram as shown in the figure below. Now see, consider the channel diagram as shown in the figure below, and the symbols 0 and 1 are transmitted. The symbol 0 and 1 are transmitted with equiprobable. Then the question is, now listen the question carefully, okay. If output equal to 0, determine probability of transmitted symbol. Probability of transmitted symbol is also 0. Now listen the question carefully first. This is very, very important. A number of times the question is asking. Now this is a channel diagram as shown in the figure below, and 0 and 1 are transmitted with equiprobable. If output equal to 0, determine probability of transmitted symbol is also 0. Okay. Now first of all, you want here, you will write here, this is x1, x2, y1, y2, such that you can easily understand. So I am already saying that probability of transmitting means p of x first, probability of receiving means p of y first. Now probability of transmitted means x by y, no doubt. Now the question is, probability of transmitting what? 0 by what is output? Output means this is transmitter means input, receiver means output. This one point also you know that. Okay. So now probability of transmitting is P of x by y, and what is the transmitting symbol? 0 by output. Y means output. What is output? Output is also 0. If output is 0 means P of 0 by 0 you want to calculate. P of 0 by 0 means this x0 means what? X is 0 means x1, which is nothing but P of x1. Y0 means P of y1. So you want to calculate P of x1 by y1 is equal to how much? That is the question. Okay. So, but what is there here? Now this is nothing but P of 0, which is nothing but P of x1. P of 1, which is nothing but P of x2. These two are equiprobable, 1 by 2, which is equal to 1 by 2. Now, this is the conditional probability P of y by x x1, x2, y1, y2. Now, y1 by x1 with a probability of 1. Now, x2 is transmitted, y1 is received with a probability of 0.25. x1 is transmitted, y2 is received, no probability. x1 is transmitted, y2 is received. x1 is transmitted, y2 is received is 0. x2 is transmitted, y2 is received with a probability of 0.75. This is the conditional probability. So now you want to find P of x comma y means, now first we require the joint probability, am I or not? Now what is the joint probability? The joint probability, which is nothing but P of x comma y, which is equal to P of x into P of y by x, because we have P of y by x, right? So you use that. Now this is x1, y1, x1, x2, y1, y2. So now this is nothing but 0.5 into 0.5 into 1, 0.5 into 0. Now 0.5 into 0.25, 0.0125. Now 0.5 into 0.75, 0.375. So now this is joint probability. Now what we want to find. Now see, this is the question which is very, I want P of x by y, but here this is P of y by x. So now you have one formula for that. P of x comma y, which is equal to P of y into P of x by y. Now what we want to calculate? Now you go for reverse. Now I want x1 by y1, sir. P of x1 by y1. Therefore this is 1. This is x1, y1. Right? So now what is the final answer? The final answer is, now probability of transmitting x1, even the received symbol is y1, which is equal to P of x1 comma y1 divided by P of y1. Now how to get P of y1? You want P of y1 or P of x1 or whatever. The row addition column addition is possible only in joint probability. So here you can get what is P of y1. P of y1, which is nothing but this column addition, 0.5 plus 0.125, which is nothing but 0.625. This is P of y1. So this answer is coming. Now this is nothing but 0.625. Is it right? Now this is P of y1. Now what is P of x1 comma y1? See here, what is P of x1 comma y1? P of x1 comma y1. This is x1 comma y1, which is nothing but 0.5. Now this is 0.5. Now this is the probability of transmitting x1 if the received symbol is y1, which is nothing but 0.8, 80% probability that. Very, very important. Now there is a similar question here. The question is, consider a binary symmetric channel with crossover probability of 1 by 7. What is the meaning of that? Consider a binary symmetric channel with a crossover probability of 1 by 7. Means, then you understand or not? Now this is the direct channel. X1 is transmitted, Y1 is received, X2 is transmitted, Y2 is received. And this is the crossover channel. This is the crossover channel probability. What is given? Consider a binary symmetric channel with a crossover probability of 1 by 7. Now this is 1 by 7 crossover probability. If this is P, this is 1 minus P. Means 1 minus 1 by 7, 7 minus 1, 6 by 7. Now this is 6 by 7. Now consider a binary symmetric channel with a crossover probability of 1 by 7 means a direct probability 6 by 7. Now this is 6 by 7 and P of x1 and x1 and x2, x1 and x2 are transmitted with x1 and x2 are transmitted with 0.2 and 0.8, which means now P of x1, the symbol x1 is transmitted with the probability of 0.2 and symbol x2 is transmitted with a probability of 0.8. This is 0.2 and 0.8. Now x1 and x2 is transmitted with this particular probability and crossover probability is 1 by 7. Now this is P of y by x. So whenever error probability is safe, then you need to identify that this is a binary symmetric channel. Binary symmetric channel. Sometimes in the question is not mentioned the binary symmetric channel. You need to identify that. So what is the question he is asking? The question here is, if the received symbol is y1, here it is mentioned clearly. If the received symbol is y1, if the received symbol is y1, determine probability of transmitted symbol. Determine probability of transmitted symbol is x2. Very clear. Okay. So probability of transmitted means P of x by y. So there is no zero case is not required because here x and y is given. So very clearly is mentioned probability of transmitting x2 when the received symbol is y1. This is a very simple question, x2 by y1. So now same procedure. So first you channel diagram and what is the conditional probability? Now this is 6 by 7. Now this is direct because binary symmetric channel, diagonal and opposite diagonal probabilities are same. Then that channel is called as binary symmetric channel. So now, which is nothing but 0.2. This is 0.2 into 6 by 7. Now this is 0.2 into 1 by 7. Now this is 0.8 into 1 by 7. Now this is 0.8 into 6 by 7. So this is nothing but 0.17, 0.02, 0.11, 0.68. This is probability. Now see here. Now this is the formula, joint probability and conditional probability relation. What I want? I want probability of transmitting x2 when the received symbol is y1. So therefore this is y1, this is x2, this is y1. So P of x2 by y1, which is equal to P of x2 comma y1 by P of y1. So now you find first P of y1, which is nothing but this is P of y1 0.17 plus 0.11, which is equal to 0.28. Now this is 0.28 P of y1 and P of x2 comma y1. P of x2 comma y1 is x2 comma y1. This is 0.11 and this is nothing but 0.39. 39% is error probability when x2 is transmitting, y1 is received. Okay, this information theory is actually 2015. Now the GATE examination is conducted in IISc Bangalore. Now there actually the information theory syllabus is changed. All subjects syllabus are changed, some additions and deletions. Now there actually they introduce all these things. Okay, earlier only entropy, channel capacity, only that much, a little bit. But now after that they will be adding all these things. Now you see here, this is a binary source. This is the binary source is generating two symbols x1 and x2 with a probability of p and 1 minus p. Okay. So now you know that this is 1 with a probability of p and 0 with a probability of 1 minus p. This is 1 and 0 with a binary source means 0 and 1, two symbols. Right? So now this binary source is generating two symbols with a probability of p and 1 minus p. So this is nothing but can I write like this, h of s dash s power 1 or h of s. This is entropy of basic or binary source, entropy of basic or binary source, entropy of a binary source. Now the question is, now this binary source is generating two symbols. Okay, so this binary source is generating two symbols. Now what I want to do it is, by using binary source, actually it is generating only two symbols. So now this binary source is extended to four symbols. So actually there are two symbols, therefore you want to extend it to one more two symbols, so totally four symbols. So this type of is called as source of extension, extension of a source, extension of source. So now binary source is actually two symbols, it is already generated. Then that source I want to extend it to a one more two symbols. This is called as second order extension. What is called as second order extension? Second order extension, which means now actually I want to generate four symbols. Now this is M1, M2. Actually this is two symbols. Now I want to generate four symbols, M1, M2, M3, M4. Four symbols. So already 2 is with the help of binary source. Now extension is how much? 2. Okay, 2 is available. Now you want to extend it to, therefore this is called as second order extension. Suppose there are two symbols are already available, but if you want to extend it to 6 more symbols, therefore this is called as sixth order extension. Total means 6 plus 2, 8, like that. Okay. So now this is, so how you can extend it with this? Now the symbol x1 and x1 possibilities x1, x2, x2, x1, x2, x2. So with the probabilities of x1 probability is p into p, x1 probability is p, x2 probability is 1 minus p, x2 probability is 1 minus p, x1 probability is p. Now x2 probability is 1 minus p and x2 again probability is 1 minus p. Okay. So this is a second order extension. Now this is called as h of s power 2 extension of entropy of second order extension of source, entropy of second order extension of source. Now similarly h of S3, which is nothing but entropy of third order extension of source, entropy of third order extension of source. Okay. Now this is entropy of second order, third order, fourth order, like that, as many as we can. Okay, then we'll solve one problem. A discrete source generating two symbols, x1 and x2 with probabilities, here I am writing 0.9 with probability, x1 and x2 with probability 0.9, and this is obviously 0.1. Then he is asking, determine entropy of basic source, entropy of second order extension of source, entropy of third order extension of source, entropy of fourth order extension of source. Like this the question is asking. So how we can possible? Only second means which is very good. Third, fourth means how we can do it. First we'll see. Now what is the h of s dash? Entropy of basic source. H of s power 1, which is nothing but basic source, is nothing but very simple. Minus of 0.9 log 0.9 base 2 plus 0.1 log 0.1 base 2. This is minus this one. Now this is nothing but 0.47 bits per symbol. Now see here. Now second order extension we will see first. Now this is a second order extension. Now the second order extension is nothing but p into p, 0.9 into 0.9, 0.9 into 0.9, 0.9 into 1 minus 0.9 is 1 minus 0.9 is 0.8. Now 0.8 into p is 0.9. Now 0.9 into 0.1. Now 0.1 into 0.9. Now 0.1 into 0.1. Okay. So now this is nothing but zero point 0.81, 0.09, 0.09, 0.01. Right. Now this is a probability of 4 symbols, and which is a second order extension for a binary source. Now what is the entropy of a second order extension of a source? Now we first see here, this is a second order extension of source, which is nothing but h of s power 2, which is equal to minus of 0.81 log 0.81 base 2 plus 0.09 log 0.09 base 2 multiplied with 2. now plus 0.01 log 0.01 base 2. Now therefore, which is nothing but this is 0.94. So can you have any relation here? If you observe here, h of S2, second order extension of a source, which is nothing but 2 times of entropy of a basic source. See here, if you want 2 into 0.47, which is nothing but 0.94 approximately, right? Now this is same or not? So now what is the relation? The second order extension of a source, which is nothing but 2 times of entropy of basic source. Now from here we can find a relation. Now entropy of third order extension of a source, which is nothing but 3 times of entropy of basic source, 3 times of entropy of basic source, and entropy of fourth order extension of a source, which is nothing but 4 times entropy of basic source. Like that you can construct for anything. So what we want entropy of nth order extension of a source, which is nothing but n times of entropy of basic source. No doubt. Differential entropy. Now we just whatever the entropy which we are identified so far, this is the entropy of a source, which is nothing but summation I equal to 1 to m p of xi log p of xi base 2. This is for a discrete source. Now this differential entropy is used for continuous channel. This differential entropy is used for continuous channel. Now in this case, the probability density function is continuous. In this case, the digital signals, the binary data is affected by noise whose probability density function is continuous. In such a situations, we generally use differential entropies. So the differential entropies, if you want to calculate here probability, for discrete source we require probability, for continuous source or continuous channels we require probability density function for calculating the differential entropy. And the differential entropy, which is nothing but h of x, continuous means integration, discrete means summation, which is nothing but minus f of x log f of x base 2 dx. This is the differential entropy, now which is for a continuous channel. Okay, no doubt. And one question is given: a continuous random variable is uniformly distributed. A continuous random variable is uniformly distributed in the interval 0 to a. Then determine differential entropy. Okay, a continuous distribution, uniform distribution is a continuous distribution. What is a continuous distribution? The continuous distribution is continuously distributed in the interval 0 to a. If this is uniformly distributed in the interval 0 to a, then this is nothing but 1 by a minus 0, which is nothing but because uniform distribution where area is always 1. So therefore f of x which is equal to 1 by A. So now, what is the differential entropy? The differential entropy is this, which is equal to minus integral 0 to A, f of x is 1 by A log 1 by A base 2 dx, which is equal to 1 by A 0 to A log A power minus 1 base 2 dx. Therefore, which is nothing but h of x, which is equal to minus minus cancel. So 1 by A log A base 2 integral 0 to A dx. So h of x, which is equal to 1 by A log A base 2 integration dx is x over the limits 0 to A. So h of x, which is equal to this A cancel, log A base 2 is the differential entropy. Now he is asking to find the differential entropy. Determine the differential entropy of a Gaussian random variable x with 0 mean. So what is the probability density function of a Gaussian distribution with 0 mean? The probability density function of a Gaussian distribution with 0 mean, which is nothing but f of x, which is 1 by root 2 pi sigma e power minus x square by mean is 0, therefore only variance. This is the probability density function of a Gaussian distribution with 0 mean. So now the differential entropy is this. Now which is nothing but integral f of x is this one. Now this is f of x, and if you find this differential entropy is integral minus infinity to infinity. What is f of x? 1 by root 2 pi sigma e power minus x square by 2 sigma square into, now logarithm 1 by root 2 pi sigma e power minus x square by 2 sigma square base 2. Into dx. Now if you simplify this, this is h of x, which is 1 by root 2 pi sigma into log 2 pi sigma e square, log 2 pi e sigma square base 2 into 1. So this is a differential entropy of a Gaussian distribution or Gaussian random variable with x with a 0 mean.